You know that it's a good idea to memorize all prime numbers under 100. A prime number has only two factors, 1 and the number itself. Some examples of prime numbers are 2, 3, 5, 7, 11, 13, and so on. In this video, challenge yourself with prime number questions. Welcome to the prime map where Optimus Prime rules. Each stage has prime number questions at the GMAT level. Are you ready? Pause the video and try the following problem. How many prime numbers between 1 and 20 are factors of 2600? Use prime factorization by writing the number as a product of one or more prime integers. 2600 is equal to 26 multiplied by 100, and it is equal to 2 times 13 multiplied by 25 times 4. Again, this is equal to 2 times 13 times 5 times 5 times 2 times 2. Simplifying the like terms, it is equal to 2 cubed times 5 squared times 13. There are 3 prime numbers. The answer is C. That wasn't hard, was it? Now let us try another stage with a little more difficult problem. Pause the video and try to solve the following question. How many prime numbers between 1 and 100 are factors of 3320? Now we need to check prime numbers between 1 and 100. How do you check if a number is prime? Here's a method to check a number's primality. First, square root the number. Second, find the integer bigger than this square root number. Third, from integer 2 to the integer found in step 2, check if it is divisible by all these integers. If the number is not divisible by all checked integers, it is a prime number. On the other hand, if the number is divisible by one of the checked integers, then it is not a prime number. In this question, 3320 is 332 times 10. 332 is divisible by 4, and we have 83. Is 83 a prime number? To check the primality of 83, square root 83. The integer bigger than square root of 83 is 10 because 10 times 10 is 100. So from integer 2 to 10, check if 83 is divisible by these integers. 83 is not divisible by 2, 3, 4, 5, 6, 7, 8, 9, or 10. Therefore, it is a prime number. We have 83 times 2 cubed times 5. There are 3 prime numbers. The answer is C. Good job! We cleared the 2 stages. Now let us try the last stage. Are you ready? Pause the video for a moment and solve the following data sufficiency question. If x is a positive integer, is x a prime number? In this question, we are given a condition that x is a positive integer. For statement 1, it is clearly insufficient because multiple answers are possible. With statement 1, we can infer that x is a prime number. However, there are many prime numbers possible, so eliminate A and D. For statement 2, it is insufficient alone because multiple answers are also possible. There are many even numbers, so eliminate B. Is the data sufficient for both statements together? In other words, is there only one answer for both statements? Yes, only one answer is possible with both statements. 2 is the only prime number that is even. Therefore, since we can get a unique answer with both statements, it is sufficient. The final answer is C. Congratulations, you mastered the prime map. In summary, to find the prime numbers, you can use prime factorization, or you can use the 3-step checking process of primality of a number. The first step is square rooting a number. The next step is finding an integer bigger than this square root. The final step is checking if integers from 2 to the integer greater than square root of the number is able to divide the number. If the number is not divisible by all these integers, then it is a prime number. Now you should feel comfortable with prime number problems. If you have any questions, please leave comments below and don't forget to subscribe and like this video. Good luck with your prime numbers.